Alright, let's keep going to the next question. So it's question number 8. And write it up here. So question number 8. Right, so let's look at this question. So the picture shows a motion diagram. So yeah, we have a picture down here. So the picture shows a motion diagram. The dots represent the object's position at moments separated by equal intervals of time. So between each dot, there's an equal time interval. So between all the dots, so between this dot and this dot and this dot and this dot, the same amount of time passes. The dots are connected by arrows representing the object's average velocity during the corresponding time interval. So these arrows represent average velocity. Right, the question here is, which of these situations describe the motion shown in the motion diagram at point A? So they give us a bunch of situations and they want us to look at point A over here and think about which situations could be represented by point A. So let's look at the answer provided by the junior tutor and let's think about what is the correct answer. So they say A and D. So reason in a velocity of a car is constant, an arrow at A is the same length, representing equal velocity, and D. So they're presenting constant velocity. So when there's constant velocity, so if we look at A car is moving along straight load at constant speed, so yes, constant velocity, and then D, a hockey puck slides along a smooth, frictionless, icy surface. So this is also constant velocity, and that's what's happening at point A. So let's go through each option and think about why it's correct or incorrect. So option A. So option A, a car moving along a straight load at constant speed. So we've already said that at point A, there's constant speed. We can see at point B the velocity afterwards compared to the velocity before has become smaller. So the object is slowing down at point A. The vector before and the vector afterward is the same, so constant velocity. And at point C you can see a shorter vector compared to the one after, and we can see that there's acceleration. So we're looking at the scenarios where there's constant velocity. A, it has constant velocity or speed, so constant speed is correct. Let's look at B. Car is moving along a straight road while slowing down. So slowing down means deceleration and a decrease in speed. So this is not constant velocity. So we'll mark that as wrong. Option C. A car is moving along a straight road while speeding up. So speeding up, we have acceleration. So they're trying to say straight road to kind of throw you off, but really you only care about if it's speeding up or slowing down. So this is also incorrect because it's not constant speed. Okay. Option D. A hockey puck slides on a smooth, frictionless, icy surface. So pay attention to this word, frictionless. Frictionless means there's no friction force, which means there's no deceleration. So if the hockey puck is sliding, it's sliding at constant speed and nothing is slowing it down. So knowing this, we know this is a constant speed answer, so we know this is correct. So in comparison to E, a hockey puck slides along a rough concrete surface. So this option is telling us there's a rough concrete surface, therefore there's a friction force that is decelerating the hockey puck, and we know that E is incorrect because it doesn't have constant speed. So E, we'll mark that as wrong. Let's go to F. So F. So a cockroach is speeding up from rest. So speeding up from rest, that's acceleration. That's pretty straightforward. That's incorrect. There's no constant speed there. So G. Right. A rock is thrown horizontally. Air resistance is negligible. So let's think about this. So if a rock is thrown horizontally, what would be happening? So it would kind of give you some projectile motion. And essentially, let's say you threw it just straight out. So you had some rock and you just threw it. in this direction, we know that there's a force of gravity acting on the rock, and it'll slowly start going downward until it hits the ground. So knowing this, we know that in the x direction, there's no acceleration force. If it's if starts off at a some speed, the speed in the x direction will stay constant. However, in the y direction, there's a force of gravity acting on it. That force of gravity accelerates the object down, so we know even though the air resistance is negligible, we know that in the y direction there's an acceleration force. So we can't say this is correct. We have to mark this as wrong. So depending on how the question is phrased, so maybe if they were a little more specific, so if the rock is thrown horizontally and we only care about the x direction, maybe then it would be true, but this is not completely true. So H, a rock is thrown horizontally, air resistance is substantial. So same idea, even when air is, adding this component here, it just says that there's also deceleration in the x direction and y direction because of air resistance now. So both are incorrect here. So H also does not have constant speed. So a rock is dropped vertically, air resistance is negligible. So I, and then J, a rock is dropped vertically, air resistance is substantial. So it's dropped vertically or horizontally, force of gravity and acceleration is always happening, regardless of which direction you drop the rock or throw the rock. So in all scenarios, G through J, they will always have that force of gravity. There's always going to be that acceleration downward. So they're all incorrect, and they don't have constant velocity, so we can't mark those as true. So X here incorrect, and J does not have constant velocity. So really the only two that we have here is A is correct and D is correct. And I believe, yes, this is the same solution provided by the junior tutor, and this answer is correct. So correct answer. Great job. And we'll mark this as correct.